Let's describe all solutions to the differential equation y prime equal to a constant times a plus a constant when y is a function on t and it goes to 5 as t goes to infinity. Alright, so what we've got going on, this little piece of information tells us that the limit as t goes to infinity of y of t is equal to 5. Alright, so something that we get immediately from this is that the limit as t goes to infinity of the derivative has to be equal to 0. Okay, so what we're going to do, we're going to take these two pieces of information, with the limit and the limit of the derivative, take the limit of both sides of this equation. So what we do, we take the limit as t goes to infinity of the left hand side, y prime, that has to be equal to the limit as t goes to infinity of ay plus, that looks like a y, plus b. Alright, well, here we know that this left hand side is going to be equal to 0, and here we know that this is going to be 5a plus b. Alright, so we can see immediately that b is equal to negative 5a. Okay, so our differential equation now, using this new piece of information, is that y prime is equal to ay minus 5a. And I'll go ahead and factor out that a. It's a outside of y minus 5. Okay, now we know from the textbook that for large values of t, if y is greater than 5, and this has to be for large values of t, y is greater than 5, then the derivative has to be negative. If y is less than 5, then the derivative has to be positive. Now this is for large values. Okay, so if we think about that, take a value of y that's greater than 5. So just any some large value greater than 5, and you'll see that this is positive. Okay, so a positive times a has to be negative. Therefore, a has to be negative. Let's think about this part. If y is less than 5 for large values of t, down here we're going to get a negative value. All right, a negative times a has to be positive, so therefore a is negative. All right, and that describes all of the situations that we have here. So we know that a has to be negative. Okay, so now let's take a look at our equation. Let's divide both sides by the parenthesis. Now we're saying that y does not equal 5, of course. Alright, well, you can notice that the derivative of the denominator is in fact the numerator. So if I integrate the left-hand side, this is actually natural log of the absolute value of y minus 5. And if I integrate the left, I have to integrate the right. This is going to be equal to a times t plus some constant. Okay, well, let's take the exponential of both sides. We have absolute value of y minus 5 is equal to e to the power of at plus c. And let's rewrite this as e to the at e to the power of c. Okay. Now, we don't know if this is positive or negative, and we don't really know what the c is. So I'm going to change this up to make this a little bit easier. I'm going to say that this is k, and like here this is positive because of the absolute value, and these guys are positive, but I'm going to drop the absolute value, and we're going to say that k could be plus or minus some value. So we have y minus 5 is equal to k times e at. So y is equal to k e at plus 5. And that is all there is to it. Oh, so to get the rest of the details, we would need to have initial values or boundary values. But with the given information, this is all we can really do.